So if you think about heavy industry, the really massive multi-million-dollar facilities, the deadliest accidents rarely happen when a plant is just humming along normally.
Right, yeah. They almost never happen on a normal Tuesday afternoon.
Exactly. They happen when the steady state shatters, when something breaks down, and the two people who are tasked with actually preventing a catastrophe, they literally cannot see what the other person is doing.
It is a terrifying scenario.
It really is. So welcome to the deep dive. Today, we are pulling apart this highly revealing press release. It's from July 16th, 2026, issued by a company called EON AI Ventures.
Yeah, and they're detailing this new integration for their work intelligence system. It's called Symbiosis.
Right, Symbiosis. And the mission for our conversation today, for you listening, is to figure out how bridging the physical and digital worlds in industrial training is attempting to eliminate these massive, catastrophic blind spots.
Because it goes much deeper than just, another virtual reality training update. What we are really examining here is a fundamental shift in the whole architecture of industrial safety.
Right.
We're looking at an attempt to finally connect the individuals monitoring complex systems with the individuals who physically interact with them, bringing them together in a shared reality, especially when lives are actually on the line.
And the way the current industry standard is described in these sources,
Yeah.
I mean, it sounds like rehearsing a high-stakes Broadway play where half the actors just never show up to rehearsal.
That is a great way to put it, honestly.
Like, you have a stage manager sitting in the booth calling lighting cues, assuming the lead actor is standing on their mark, but the stage is completely empty. How on earth do you know if the scene actually works before opening night?
You simply don't. You don't know. And the industry has, well, decades of grim accident data to prove it, unfortunately.
Yeah, which is just wild to me.
But before we can really grasp why the symbiosis technology is such a big deal, we have to establish exactly where and why things go so terribly wrong in a heavy industrial setting. We have to look at the moments when that missing team dynamic turns fatal.
Right, and the source material points out something that feels almost counterintuitive at first.
How so?
Well, major industrial disasters don't usually cluster around normal day-to-day operations. They happen during what the industry actually calls abnormal operations.
Yes, that is the crucial vulnerability right there. We are talking about startups, shutdowns, and sudden upsets.
Ah, okay.
So imagine a massive oil refinery at 3 in the morning when a steady state is broken, pressures change rapidly, temperatures fluctuate wildly, and, human intervention becomes the absolute only thing standing between control and total chaos.
It sounds incredibly stressful.
Oh, it's a highly dynamic, incredibly high-stakes environment.
And the core failure pattern behind many of the worst disasters during those abnormal operations, it isn't necessarily a faulty pipe or a broken pressure gauge, right?
Okay.
It's a lack of human coordination. It is a profound communication breakdown between two very specific individuals. You've got the board operator sitting in the control room and the field operator out on the actual plant floor.
Right, because the control room and the field, they each only hold half of the picture.
Just half.
Yeah, the board operator sees the mathematical data, the pressures, the temperatures flashing on their monitors. But the field operator, who might be, 2 miles away in the rain, sees the physical reality.
Like a leaking valve.
Exactly, a leaking valve, a vibrating pipe. And to solve a crisis, those two isolated workers have to merge their mental pictures perfectly over a radio.
But the way they train for this dynamic is just, it's wild to me. Traditionally, those board operators train on these incredibly rigorous, expensive process simulators. They sit at a console that looks and feels exactly like the real thing.
Which is great, but there's a huge piece missing.
Right. Because in those drills, the field operator, the person actually out there turning the physical wrenches, is totally imaginary. The sources mention that a trainer literally just stands next to the board operator and says, assume the valve is closed.
Yeah, assume it's closed. Meanwhile, the actual field operator is training entirely disconnected from that expensive console simulator.
Just completely separate.
Completely. They might practice walking through the physical plant or reviewing paper procedures in a sterile classroom, but they are not doing it while a board operator is simultaneously reacting to their physical actions on a live system.
Wow.
So, the two halves of the organizational brain are completely severed during the learning process.
Okay, let's unpack this because I am struggling with the logic here.
Sure.
If we are talking about multi-million-dollar facilities that handle highly volatile, hazardous materials, how has the industry survived this long without rehearsing the most crucial conversations?
It's a fair question.
I mean, it feels like a pilot flying a state-of-the-art flight simulator.
Mm.
But air traffic control is just a sticky note slapped on the dashboard that says, assume you are cleared for landing. Why wouldn't they have connected these two training worlds decades ago?
This raises an important question, and honestly, the answer comes down to a massive technological language barrier.
A language barrier.
Yeah, basically. Historically, simulating the precise mathematical physics of a whole industrial plant, so the complex fluid dynamics, the thermodynamics, that was one incredibly dense technological language.
Right.
But tracking the precise spatial actions of a human being walking through a facility and turning a specific physical object, that was an entirely different technological language. They simply could not speak to each other without crashing.
So it wasn't a lack of desire from the plant managers. It was literally just a lack of translation between the software.
That is the core of the problem right there. The process model in the control room simulator operates on tags and numerical data points. It is purely math.
Okay, math.
But a virtual reality simulation of a plant, what we call a digital twin, that operates on 3D geometry and spatial coordinates, for a long time, bridging those two worlds in real time was computationally unfeasible.
Wow.
And the tragic result is that the exact conversation that fails in real-world accidents, that frantic coordination between the board and the field, is the exact conversation that is never rehearsed.
That is a chilling thought. The exact conversation that fails is the one that is never rehearsed.
Exactly.
But surviving a single virtual drill doesn't fix a systemic issue unless you can somehow merge those two languages.
Right.
And that is what this press release is claiming. EON AI Ventures says they have finally built the translator to put both operators into the exact same virtual disaster at the exact same time.
Yes, they announced a direct console simulator integration for their Symbiosis work intelligence system.
Okay.
They are taking the high-fidelity operator training simulators, the legacy systems made by major vendors like Honeywell, AVEVA, Yokogawa, and Emerson, and they are linking them directly to EON's own physics-true digital twin.
So paint a picture for us. How does a joint training session actually work now with this integration in place? Let's say we are simulating a pressure valve failure.
Okay, so a training team begins by selecting an accident scenario from EON's Situation Room.
The Situation Room.
Right. And this is a library built from real historical industrial accidents. They aren't relying on generic theoretical drills. They are using past documented disasters as the actual blueprint.
Wow. Learning from the actual scars of the industry. I love that.
It's very effective. So once the scenario starts, the board operator sits down at their standard control console. Their environment is completely unchanged.
So they don't even know it's the new system.
Exactly. They are looking at the exact same screens and pushing the exact same physical buttons they would on a real shift. Meanwhile, the field operator enters the EON digital world.
Okay, and how do they do that?
They can do this in a few ways. They might interact with a 3D digital twin on a desktop computer. They could put on a full virtual reality headset, or they can even be out in the real physical plant using something called Field IQ on a mobile phone or augmented reality glasses.
Okay, here's where it gets really interesting. How does the plumbing of this actually work?
The plumbing.
Yeah, because, well, hold on, I'm losing the thread a bit. We were just talking about turning virtual wrenches, and now we are edging into acronym territory. How does a field operator in a VR headset turning a purely geometric virtual wrench actually cause a mathematical alarm to go off on a totally separate physical control board sitting in another room?
Okay, let me give you a better way to visualize it. The architecture relies on a lightweight, vendor-neutral bridge. And the foundation of that bridge is an existing industry-standard protocol called OPC-UA.
OPC-UA, got it.
Think of OPC-UA like a standardized data format. It is essentially an API that allows a Mac and a PC to edit the exact same Google Docs simultaneously without corrupting the file. It is the universal syntax for industrial communication.
Okay, so they have a shared document. But how does the Mac know what the PC is typing? Like, how does the 3D VR world talk to the math-based simulator?
That happens through something called a tag map. Think of a tag map like a massive real-time dictionary.
A dictionary, okay.
It specifically pairs the process tags from the console simulator. So, for instance, the numerical data point for the pressure in tank A,
Yeah.
it pairs that with the physical 3D components in the digital twin, which is the geometric model of tank A.
Oh, I see. So the dictionary links the mathematical variable directly to the visual object.
Exactly. Let's walk through the exact millisecond it happens.
Right.
The field operator is in VR. They reach out and close a virtual valve. The system registers a change in spatial coordinates.
Right.
That action triggers the tag map. The action translates across the OPC-UA bridge live, so the console simulator's process model receives the data that the valve state is now closed.
And then what happens on the board?
The legacy simulator recalculates the fluid dynamics based on that new variable, and the pressures instantly start dropping on the board operator's physical screen exactly as they would in reality.
That is just mind-blowing. They're literally sharing a reality across two entirely different types of computing.
It really is a massive breakthrough.
But that leads to a huge philosophical design question for me. When you take two massive pieces of enterprise technology, right? A legacy process simulator from a giant company like Emerson and a cutting-edge 3D digital twin from EON, and you smash them together, how do they not just override each other and crash? I'd imagine they both want to be in charge of the simulation.
The source material is very clear that the design philosophy is strictly complementary. They deliberately divide the labor to avoid that exact collision. The console simulator's process model remains the absolute, unquestioned single source of truth for the unit's process dynamics.
Because companies like Honeywell and Yokogawa have spent, decades and billions of dollars refining the math behind how those specific chemicals flow, boil, and react. So EON isn't trying to arrogantly rewrite the fundamental laws of physics here.
Not at all. EON Live, which is the real-time physics layer of their digital twin, scopes itself purely to equipment-level physics and the visual world.
Okay, making sure that visuals match up.
Right. It handles the gravity of a dropping wrench, the visual spray of a chemical leak, and the spatial movement of the field operator walking up a flight of stairs.
There is a fantastic quote in the release from Dan Legerskar, the founder and chairman of EON AI Ventures, that perfectly captures this division of labor. He says, "The console simulator is the brain of the unit. Work intelligence is the world and the body. We did not build this to replace anyone's process model."
Yes, and he finishes that thought by explaining they built it so that, for the first time, the board and the field can live through the same accident together, safely, and come out of it as a unified team.
Let me push back for a second, though. I love the brain and body analogy. So they aren't trying to build a better brain. They're just giving the existing brain a nervous system and eyes.
Right.
But doesn't adding a whole new visual spatial layer risk, creating more lag or more points of failure during a critical drill? Like, if I am a plant manager, I might worry that overcomplicating my perfectly good simulator just gives me a bunch of new software bugs to deal with when my team should be focused on the drill.
What's fascinating here is how EON addresses that exact fear by fiercely focusing on vendor neutrality and that OPC-UA standard.
Okay.
By explicitly not attempting to replace the process model, EON allows a facility's existing investments to become what Legerskar calls doorways rather than silos.
Doorways, not silos.
Right. They aren't asking a plant manager to rip out and replace their multi-million-dollar Honeywell system. They're saying, just plug our lightweight bridge into it. The goal is unity without redundancy.
So it is about maximizing the massive capital investment they have already made in the control room.
Exactly. A console simulator purchase used to be an entirely separate world from the field operations budget. Now, you plug it into work intelligence, and that same legacy investment suddenly becomes the engine training both halves of the team simultaneously.
That's a huge win for them.
It represents a massive efficiency gain for enterprise training budgets without introducing competing physics engines.
Okay, so they survive the virtual accident together. The virtual valve is closed, the virtual pressure drops, the plant is saved. High fives all around.
Job well done.
Right. But if you just run the drill, take off the headsets, and wipe the server, you have totally wasted the most valuable byproduct of the entire exercise.
Oh, absolutely.
The sources detail what happens to all the data generated after the drill, and this is where it transforms from a cool training exercise into a permanent corporate asset.
We are getting into what EON calls their intelligence flywheel. And when you look at the architecture of the system, this is arguably the most powerful component of Symbiosis.
Let's figure out how this flywheel actually operates. Because if both operators are in the same digital space, there has to be a footprint, right?
There is a massive footprint.
They are generating a digital record of every single decision, every button pressed, every valve turned, and every second of hesitation.
Exactly. And all of those documented actions become what the press release calls measurable deltas.
Break that down for us. What is a measurable delta in practice?
So, a measurable delta is the exact quantifiable difference between what the official standard operating procedure expected the human to do and what the human actually did under the stress of the simulation.
Oh, I love that. Give me an example.
Okay, let's say the manual explicitly states, check the pressure gauge, wait 10 seconds, then turn the bypass valve. But during the joint drill, the system records that the field operator turned the valve immediately without waiting.
Why would they do that?
Because in the real world, they know that specific gauge always lags. That deviation is a measurable delta.
Oh, that is huge. Because anyone who has ever worked a complex job knows that the binder sitting on the manager's shelf and the reality on the floor are rarely the same thing.
Exactly. And EON utilizes a tool called a SESIQ that constantly measures these deltas in the background of the simulation. It looks at the gap between the idealized expectation and the messy reality.
Right.
It then presents that behavioral data to the trainees, the trainers, and the management level.
But they don't just use it to hand out a grade at the end of a test, right?
No, no.
They feed it into another tool called Compound IQ, which takes those measurable deltas, those incredibly valuable lessons learned from human mistakes, shortcuts, or improvisations, and turns them into durable compounding knowledge right inside the digital twin.
It creates a continuous feedback loop. Every single joint drill makes the scenario for the next drill sharper and more realistic.
It's always improving.
Yes, it even pushes updates to the facility's day-to-day guidance on those augmented reality glasses.
Ah.
The system is actively learning from the humans just as much as the humans are learning from the system.
And it is really worth noting the pedigree behind this. EON AI Ventures isn't some fly-by-night startup that just appeared yesterday to capitalize on a VR trend.
Definitely not.
The release points out their heritage spans over 25 years in immersive learning. We are talking about over 4,400 institutional customers across 80-plus countries and a staggering 136 million platform downloads.
That's a huge footprint.
Yeah, they have built this flywheel on a broad vision they call One System, Human 2.0.
That kind of historical scale is critical context because it means this flywheel has a massive amount of historical data and structural experience fueling it. It is built to operate reliably at a global enterprise level, not just as a pilot program in a single facility.
So what does this all mean? Like, if you're listening and you don't happen to run an oil refinery, if you manage a hospital wing or a team of software engineers or a logistics hub, why should you care about measurable deltas?
It's universally applicable.
I think it comes down to this. This technology completely exposes the lie of the standard operating manual. It reveals that how work is supposed to happen in a sterile boardroom and how humans actually behave when the alarms are blaring are two totally different things.
If we connect this to the bigger picture, what EON AI Ventures has built is the missing system of record for human work. They call it work intelligence for a very specific reason.
Right, work intelligence.
Enterprises have robust systems of record for their finances, for their supply chains, for their customer relationships. But historically, human experience, instinct, and error have vanished into the ether the exact moment a worker's shift ends.
The knowledge literally just walks out the door when a veteran operator retires.
Exactly. But with this intelligence flywheel, every joint drill, every captured delta turns ephemeral human workflow into an owned, compounding digital asset for the whole enterprise. You are no longer just buying an isolated piece of training software.
You're building a library.
You are building a permanent repository of actual, unvarnished human behavior.
Well, we have covered some truly fascinating ground today. We started by looking at the catastrophic blind spots in heavy industry, those terrifying moments during abnormal operations where the control room and the field operator are dangerously disconnected.
Right, the missing team problem.
Yeah. And then we explored how EON AI Ventures Symbiosis integration uses the OPC UA protocol and tag maps to translate and bridge the mathematical brain of the legacy control room simulator with the spatial body of the 3D digital twin.
We also broke down how that integration feeds the intelligence flywheel, capturing those measurable deltas between idealized procedures and actual human behavior.
Turning those gaps into real knowledge.
Exactly, turning those gaps into compounding, durable knowledge that improves the entire organization.
As I mentioned a moment ago, the concept of breaking down silos to capture actual human workflow is a profound shift for any learning organization. You have to ask yourself, in your own work environment, are you training with half the team missing? Are you capturing the measurable deltas? Or are you just pretending the manual is the absolute truth?
It does leave us with one final, rather provocative implication to consider that isn't explicitly stated in the release.
Oh, let's hear it.
Well, If this intelligence flywheel is constantly measuring these deltas, the precise gaps between expected procedures and actual human behavior under stress and permanently storing them in a digital twin,
Yeah.
could we eventually accumulate so much human error data that the AI behind the system begins to predict an operator's mistake before they even touch the physical valve?
Wow. Predicting the failure before the human even makes the conscious choice to act. That is a heavy, incredible thought to leave on.
It really changes
It
everything.
brings us right back to our Broadway play analogy. We started by imagining the chaos of rehearsing with half the actors missing. Now, imagine a stage manager who has watched so many rehearsals and collected so much behavioral data that they know an actor is going to miss their cue before they even step foot on the stage.
The power of compounding knowledge.
Exactly. That is the raw power of compounding knowledge. Thank you so much for joining us on this deep dive. Keep questioning how your own organizations capture and value knowledge, and we will catch you next time.